Ahmed Elkad from Delares. So next presentation is Delares. I think we can start promptly. Thank you very much.
Okay, thank you. I have also a disclaimer. Well, I got the message that I need to present something as an overview of what we do in terms of offshore geotechnics. So I didn't dig deep in one of the topics. I'll give a highlight of what we do and just a couple of examples of the project we are running at the moment. So offshore geotechnics at Delares and a bit of focus on the monopile research we do. The bigger picture is that we do a lot on offshore, not only the technical part, but we have also the hydraulic, the geologist, the geophysicist. So we have morphology, hydrodynamic, and that's in terms of numerical, experimental, field testing. So we do a lot of integrated, let's say R&D, but also consultancy. But I'm focusing on the geotechnics. In sake of time, I'll not go through all this. But yes, that's what I just mentioned. Now we do hydrodynamics, we do morphology and morphodynamics, geotechnics, which I will give a bit more detail on. Things like corrosion, so we have geochemistry, biochemistry, ecology, which is a lot of work at the moment, especially also for the new tenders in the Netherlands. So aquaculture, but also nature inclusive design. It's a big topic that we contribute to. And what we call here miscellaneous is the co-use of offshore wind farms, for example, floating solar, in coastal, in the sea, but also in freshwater, energy islands, and so on. When we look at the geo part, well, first introduce a bit the team. So this is the core team, I would say. So it's not a very large group, but the unit geo is about 100 people. So this is the ones that are really focused maybe on offshore. And we are, of course, supported by around 90 more extra colleagues. If I want to sum up what we do, it's basically dynamic solid structure interaction. So dynamic can be static, of course, but that's in general the work we do in offshore. A lot on foundations and specifically monopiles. But we do things also around infrastructure like pipelines. And when it comes to offshore, then we are talking about landfall operations of cables, for example, when they are done by HDD techniques. A lot of numerical modeling, experimental, but also in the field, scaled modeling, and risk assessment. When it comes to monopiles, I think in the last 5 or 6 years, we have really done a lot on installation techniques. So that is what I will also focus on. A bit on decommissioning as well, and a lot on validity of new installation techniques. That's also something that is really growing in the Netherlands, alternative to impact hammering. In terms of pipelines and cables, I just mentioned also briefly, there's also installation in it, and that's new techniques compared to, for example, horizontal directional drilling, interaction with the soil. Nowadays, there is a lot of focus on converting infrastructure from gas to hydrogen, for example. This is onshore, not offshore. But offshore, we do a lot on cables and landfall operations and cable lifetime, let's say, assessment. So I mentioned numerical, and when it comes to numerical and monopiles specifically, we do a lot on MPM. So we developed our own code, material point method, and we use that for installation problems. That can be a cone penetration testing. It can be also actually a pile penetration or installation. And we have done for impact hammering. We are doing now for vibratory, so definitely more challenging. But it's also used for other problems which is related to offshore, like, let's see, deep sea sand cutting, for example. So the MPM is developed, and of course, cognitive modeling is very relevant. So we do also on cognitive modeling, but we also collaborate a lot on that part. One of the things we've done recently with MPM, looking at one of the risks you always encounter when you're installing monopiles or piles offshore is a run-up. And if you have interface between layers, you want to assess this risk. So here we are looking at sand transitioning to clay and what we can expect in terms of forces. So on the left side, we see actually material points that are moving under or in front or next to the pile. So this is the pile wall. It's an open channel. It's an open pipe, if we can call it that. And you see when it's transitioning between sand and clay, what is happening here. But you also this very clearly in the reaction forces. So there's quite a transition zone between dense sand and what's somewhat softer clay. In terms of monopile R&D, we have different projects. Most of them are still running. On the design, something called Gypmidas, which we are developing PY curves for cyclic loading, a lot of centrifuge testing. Juan can tell you all about it. He done it himself. And on an installation, we started long ago with MPM, so numerically, and then we moved to different projects, which include experimental and field testing. So data was mentioned today. We're actually trying to generate a lot of data, hopefully high quality as well, for numerical validation, but also for design guidelines. And we also did and still doing some testing on or working on decommissioning alternatives. The largest project we are working on, Gypsymox, I will explain also in the next slides, is running since last year. And the other one on decommissioning is hydraulic pile extraction. So these will be the focus in the next slides. Cymox is a joint industry project, in total around 6.5 million euros. We get around 4 million euros in subsidy from the Dutch government. 3 years project, and we have about 22 partners in this project, between academia, contractors, offshore wind developers. So it's more or less the whole supply chain, but also monopile manufacturers. The intention is, maybe it's a little bit not clear, but in the Netherlands, there have been at least 3 or 4 ideas on alternative installation techniques, mainly based on vibration, with different combinations, with jetting, with high frequency rotation. And they have been developed in different projects. And the industry wanted to actually have one project where we can compare these technologies, where we can also produce a data set comparing them in the same conditions in the lab or in the field, to be able to bring one of them at least further for certification. So it's an industry push. And the technologies will be tested in this project in different conditions. The technologies are the standard axial vibration, so that's known. Something called GDP, gentle driving of piles, developed mainly by the TU Delft and in different projects, where axial vibration with low frequency combined with very high frequency torsional vibration, which we call the GDP shaker. And we're talking about 60 hertz torque and maybe between 15 and 18 axial. Vibrojet is jetting at the pile toe, combining with vibration at the top, and comparing all to impact hammer as a reference. So the GDP is developed earlier, and we had a proof of concept project where you see the shaker already here. And as I mentioned, it's a combination between axial and torsion. And the first proof of concept, so a bit of sound to manage the afternoon dip, is mainly done in what we call the Maasvlakte. It's a reclaimed site in Rotterdam in the Netherlands, dense sand, and we have seen that it works. It works in installation. It works also in decommissioning. So this was an 80 centimeter pile, penetrated for around 8 meters in the soil. What we do within Cymox is different things. We start with lab testing. We just completed the lab testing at the Delares facility. And we do this in cylinders, which similar to the chambers we have seen today. And we also do it in what we call the soil water flume. And then we're going onshore for a dense sand site where we will test piles in the order of 2.2 meter diameter, 11 meter long in the soil. We have an offshore campaign for noise. So these are more on the drivability, lateral bearing capacity under cyclic and monotonic loading. And we're going for offshore campaign to measure also noise in the near and far field. And this is related to the onshore testing. So how we will be testing it on the onshore. The centrifuge is planned as an, let's say, if needed. We didn't yet do testing for this project. We did a lot on Midas, but we'll see if maybe later we need extra data, we can go for centrifuge testing. So this is how the lab testing would look. We have a big basin where we could condition the soils. We have sand, we have densified the sand. We installed piles in it. And we had vibratory tool and an impact hammer tool where we can actually use in that facility different combinations between impacts and vibration. And all of these piles have been, so different batches also, we have been laterally loaded, so under cyclic loading. So at this scale, we managed to check drivability, a lot of instrumentation, but also lateral bearing capacity. So the impact hammer was selected to as much as possible represent the energy we get onshore or offshore, and the same with a suitable vibratory tool as well. So the piles at this scale were installed using, I would say, realistic installation techniques in the facility. We are now processing the data, so I don't have results yet. We just finished a couple of weeks ago, and we are processing the data and planning for onshore testing Q1 next year. The other one is the jetting project as an example. We started with a startup called GBM Works in the Netherlands a few years ago, developing the concept where the jetting can be combined with vibro, but also maybe with impact later if we want to. And this could be useful for some soils where we cannot penetrate with axial vibration. So what happened is we started in 2020. GBM Works or the Vibrojet will be part of CIMOC, so you see the interaction between the different projects as well. And they will go offshore as a separate project to test at more or less full scale. So this is a bit the development plan. Decommissioning, maybe another example. We know all the thousands of monopiles now we are installing in the North Sea at least will be decommissioned in 20-25 years. Even if there is an extension of life, there will be a decommissioning moment. So some industrial partner together with us started to think about how can we actually decommission these piles. Well, one of the main questions, can we retrieve the full pile, so the whole steel? We're talking about thousands of tons of steel that are in the ground. So we started with a very simple look and feel test in our lab where we had this glass. No, it's kunststoff, plastic, yeah, plastic pipe. We have sand. We filled it with water. The whole idea is that after you remove the top structure, you actually seal the top of the monopile. You fill it with water, can be seawater, and start pressurizing inside. Once you pressurize enough, at a certain moment, you will be able to come over the friction and the pile will start moving. And that's closer to what we will see here, but we also did testing as a proof of concept, which I will just show you. So here, at a certain moment, the pressure is enough to overcome the friction and the pile starts to move. So we did some testing again in our facilities, and in this case, we did sand and clay. We could produce our own clay with around 50-60 kilopascal. I'm not going maybe through this for the sake of time, but we can produce the clay and install the piles in that clay, but also in the same procedure in the sand. So we had similar procedure to the other project that I showed you. Again, we had the possibility to use installation techniques. So here we have impact hammering. So we only used impact hammering this because we were more concerned about decommissioning. So that is how we did it. This is in clay. This one is in sand. So what we did after is, again, we pressurized inside the pile. We had several instrumentation to see what's happening. But of course, the major question for us was the outbreak pressure, at which pressure we need. And of course, there has been also modeling next to it because the industry is interested to know when I go offshore, can I actually realize these pressures or not? So this is the question. Several measurements about displacement, the pressures, the flow, and different combinations. So we had clay, we had medium dense sand, we had dense sand. We had longer setup, so we looked at setup effects. We looked at dense and clay, so a bit of layering. We also looked at possibilities to, okay, what if I have leakage? So if I cannot maintain pressure. So we used bentonite at the top, and after some excavation to seal inside the pile and apply pressure again. So all this we did also at 2 scales, 1 to 20, 1 to 30, compared to 8-meter diameter monopile. And so we had quite some data out of this, and we also did some mechanical pull tests. What we could see, okay, it works. Of course, there are some challenges at certain combinations of either soil or layering. And we could, as at first result, also see the differences between the different scales and between the different soils on the outbreak pressure and validate our model. And what we are doing now is we are having another project where actually Ton is involved in, to go to the field and test 1.5-meter diameter piles and see. So this is lab scale, and now we are going to the onshore still before going to offshore. And yeah, at this scale it works, so we are hopeful that it will continue proving the concept also at the bigger scale we are testing now in the north of the Netherlands. That's it, I think, for my presentation. Thank you.
Thank you very much, Ahmed. We have time for some comments. Anyone from the audience? Yes, please.
To each other, we assume this point are tangent, almost tangent to each other.
Thank you very much. It's very interesting to see all this experiment on the commissioning, which is, it's gonna come upon us sooner or later.
Yeah.
I was wondering how important was the setup? I mean, for how long did you wait for the setup, and how important it was in the press room? Like, if you could.
On let's say in general, we didn't see. So we waited for a week. Okay. And we didn't see much effect from the setup in that case. We are planning to do more testing on setup in the other projects as well. So we will include this in Simox, but maybe also in HYPES, the follow-up in the onshore testing. And we have done a lot on the desk studies, let's say, and literature on that. So, and you know that there are confusing messages about it, but we include it in the new programs as well. But for the decommissioning, we didn't see a huge effect.
Okay, thank you. Maybe we can move forward.